Here we have a problem on derivative. There is a function given over here and we have to find dy over dx. That is, we have to find derivative of y with respect to x. Actually, the given function is an implicit function. Okay, so let's consider another function, that is y is equal to something 5x squared positive 3. Okay, here in this function, it is solved for y in terms of x. Then it's called explicit function, this one. Okay, if I want to find dy over dx in this explicit function, it's a little easier than the one what we have. So because here it has been solved for y. So if I find the derivative of this y on the left side with respect to x, I'm getting dy over dx. On the right side, I can find the derivative of this stuff with respect to x. So I can get dy over dx easily. But in our function, y, it is not solved for y in terms of x. So it's called implicit function. So how can we get dy over dx in this function? So what we need to do is we have to find derivative on both sides of the given function with respect to x. At last, we have to solve for dy over dx. Okay, first let me write the given function as it is. That is x squared times y squared positive 3xy positive y equals to 0. Okay, now let's differentiate on both sides with respect to x. Let me do it. Okay, here when I'm trying to find derivative of the first term x squared times y squared, so here two terms are multiplied and both the terms contain variable x and y. So whenever I want to find derivative of a product where we have a product of two variables, I have to use a product tool to get the derivative. What is product tool? Okay, now let's consider the product of u and v. Let's assume both u and v are variables and I want to find derivative of this product, that is u times v prime. So what I have to do is I have to keep the first term u as it is and I have to get the derivative of the second term v, then I'm getting v prime. Now I have to take positive sign. Now I have to get the derivative of u, that is u prime. I have to keep the second term v as it is. So this is called product rule. So the same product rule I'm going to apply to get the derivative of the product x squared times y squared. Okay, so what should I do? I have to keep the first term x squared as it is. Now I have to get the derivative of the second term y squared with respect to x. So how can I get the derivative of y squared with respect to x? Okay, for that, let's consider the stuff x to the nth power. I want to find derivative of this one. So when I want to find derivative of any stuff which is in the form of x to the nth power, so what I should do is I have to bring this exponent in n in front of the variable and I have to subtract 1 from the exponent. So this is the derivative of x to the nth power and this is called power of derivative, that is getting exponent in front of the variable and subtracting 1 from the exponent. Okay, if I apply the power of derivative in this y square, what I need to do is I have to bring this exponent 2 in front of y and I have to subtract 1 from this exponent 2, then I'll be getting 2 negative 1, so which is 1. Okay, so anyways, whenever the exponent is 1, we don't have to mention. So far I got derivative only for the square. By chain rule, I have to do further derivative for the base y with respect to x. When I do so, that is when I find the derivative of this base y with respect to x, I am getting dy over dx. Okay, now I have completed the first step of the product rule. That is, I kept the first term x squared and I got the derivative of the second term y squared using the power of derivative which I have explained over here. So I use the power rule over here in y squared because this y squared is in the form of x to the nth power. Okay, now let's do the second step of the product rule. That is, I have to keep the first term. I have to find the derivative of the first term, that is u prime. I have to keep the second term as it is. Okay, now if I find the derivative of the first term x squared, again I have to use the product rule because x squared is in the form of x to the nth power. Okay, to get the derivative of this x squared, what should I do? I have to bring this exponent 2 in front of x and I have to subtract 1 from the exponent 2. When I subtract 1 from the exponent 2, I'm just getting the exponent 1. So whenever the exponent is 1, we don't have to mention. Okay, now I got the derivative of the first term x squared. I have to keep the second term y squared as it is. Okay, now I got the derivative of the product x squared y squared, x squared times y squared using the product rule. Okay, now positive. Okay, now let's find the derivative of the second term 3 times xy. So here the product xy has to be considered as variable part because here x and y are multiplied but both of them are variable. So the whole stuff x times y as variable part. So this variable part is multiplied by a constant. So when I want to find derivative of a product where a constant is multiplied by the variable, I have to keep the constant as it is and I have to find the derivative of the variable alone. But if I consider the variable part over here, two variables are multiplied. So the same thing, product rule, that is I have to keep the first variable x as it is and I have to get the derivative of the second variable y with respect to x, then I'm getting dy over dx. Positive. Now I have to get the derivative of the first variable x with respect to x, then it becomes 1. I have to keep the second term y as it is, times y, positive. Now I have to get the derivative of this y with respect to x. I'm getting dy over dx equals to 0. Okay, now we have to do simplification. So when I multiply x squared times 2y, I'm getting 2 times x squared times y times dy over dx positive, 2 times x times y square positive. Now I can multiply, I can distribute this 3 to these two terms inside the square bracket. When I distribute this 3 to x times dy over dx, I'm getting 3 times x times dy over dx. When I distribute this 3 to 1 times y, it's just 3y, because already we know that 1 times y is y. When I distribute this 3 to y, it will become 3y. That is positive 3y, and positive dy over dx equals to 0. Okay, now our aim is to find dy over dx. So let's keep the terms on the left side which contain dy over dx, and we have to get rid of the terms which do not contain dy over dx. So there are two terms on the left side. They do not have dy over dx. So we have to get rid of these two terms. So for that, I subtract 2xy square from both sides. Let me do it. And also I subtract 3y from both sides. So when I do so, let me do this. This positive negative term will cancel. The same thing will, over here, and I'm getting 2x squared times y dy over dx, and positive 3 times x times dy over dx, positive dy over dx. On the right side, we have negative 2xy square, negative 3y. Okay, here on the left side, all the three terms are contain dy over dx. So we can factor dy over dx out. If I factor dy over dx out, then in the first term, I have 2 times x squared times y positive. In the second term, I have 3x. In the third term, I have 1. So if I distribute this dy over dx to this one, this one, this one, I must be getting the expression over here. So when I distribute dy over dx to the three terms inside the parenthesis over here, I'm getting this one. So the factoring I've done over here is correct. And also on the right side, when I look at the expression over here, both the terms are negative, and also the greatest common divisor for these two terms is y. So I can factor negative y out from the terms over here. So when I factor negative sign out, the first term is having already negative, so it will become positive. When y is factored from this one, I'm getting 2 times x times y. Since I factor the negative sign out, this negative 3y, this negative sign will become positive. Since y is also factored out here, so I just have 3 over here. So this is a factor form of this expression. Okay, now let's verify the factoring, what you have done is correct or not. So if I distribute this negative y to this 2xy, it will become negative. Y times 2xy will become negative 2xy square. Okay, so negative times positive will become negative. Y times 3 is 3y. So the factoring, what I have done is correct. Okay, now let me continue the step over here. Let me take the same equation over here. That is dy over dx times 2 times x y square positive 3x positive 1 equals to negative y times 2xy positive 3. Okay, now our aim is to solve for dy over dx. So I have to get rid of the expression which is multiplied by dy over dx. So let me divide both sides by 2xy square positive 3x positive 1. And here 2x y square positive 3x positive 1. So this one will cancel out. I'm getting dy over dx equals to negative y times 2xy positive 3 over 2 times x y square positive 3x positive 1.